Okay, so what we're going to do is a quick refresher on algebra and things that you're supposed to already have done. So what we're going to be doing is we're going to look at the operations with algebra. We're going to look at variable substitution. We're going to look at subject of the formula. And finally, we're going to look at some powers or exponents or indices. So the first one we're going to start off with is operations with algebra. And we're just simply going to look at a couple of examples and try and understand how they work out. And you would mostly see how we are going to apply these topics in later videos. For example, the operations with algebra, you're going to notice how we use it in units. But for now, just try and remember how to do it. So I'm just going to go through a couple of examples. Let's look at the example of 3x plus 4y equals. We can see here right away that we don't have the same variables here and here, so we can't add them with each other. In algebra, when you have something like this, you just simply leave it as it is. If, however, we have something like this, then we get the answer 7x. Or similarly, if we have something like this, we get 3y. And we can keep doing anything like that constantly, as long as we have the same value. And I'll just put it in a different color. As long as we have the same symbol here, we can put them together and just add the numbers. Notice we have the same symbols here, and we just put them together and we have the same symbol here. Why this works? This symbol here usually represents a quantity or an item or an object that you're going to be dealing with. So let's say, for example, we have something like apples. If you have 5 apples and you give away 2, you're left with 3. So math, when you were doing algebra and you were using these x and y symbols, you were just simply replacing the objects themselves with you're replacing the objects themselves or the name of the object themselves with just simple symbols that are easier to manipulate. After all, you don't want to keep writing things like apples and apples all over again. Next, we're going to look at multiplication and division for these same operations with algebra. When you have any two terms that are multiplying by each other, you don't really consider the symbols or worry about the symbols. You just simply combine them. So in the case of having the same symbols when you're multiplying, you would do something like this. You would first multiply the two numbers together, which is 6, and then you would multiply the letters together, which is x squared. Let's say, for example, you have something else like 7x multiplied by 2y. We first multiply the numbers together, we get 14, and then we multiply the letters together, we get xy. So you would see how this would be used in later units when you're deriving units. This is very important when you're deriving units. Let's say we have, for instance, a division. So 2a cubed divided by a squared. We will literally be cancelling off the powers. So this here means 2a multiplied by a multiplied by a. So we just simply cancel off the a's that are in common. Remain with 2a. Then we can follow the same procedure for another example. Let's say, for instance, we have 15b squared over 3b. Cancel the numbers first, we get 5, and then cancel the letters, we get b. You can do any combination of multiplication and division together. So, for example, I can take both of these and combine them to get one solution to something. For example, if I take 7x multiplied by 2y divided by, let's say, 3b, I would simply cancel off the top part with the bottom part, and I would combine the top parts together. So I'll get something like 14xy over 3b. And since 14 can't divide 3, since 3 cannot divide 14 evenly, I will leave it as a fraction. The next topic we're going to look at is variable substitution. Now, variable substitution is used most of the time when you're encountering formulas in physics. When you did variable substitution in algebra, they would give you a question such as this. They would tell you A is equal to 1, B is equal to 2, and C is equal to 3. And then they would tell you, okay, well, figure out the value of A squared plus C minus B. And you would do the substitution first, which is replacing the A with a 1. You're putting it in a bracket. And then you're replacing the C with the 3, so you put that in a bracket. Whenever you do your substitution, remember the variable that you're substituting, just remove it and replace it with a bracket plus the value, so minus, like that. When you put it in a bracket like this, it helps you deal with positives and negatives easier. And you won't see it in this one here, but this here is understood to be a positive 2. So when you're multiplying a negative, and this here is outside here is understood to be a negative 1. So when you're taking this negative 1 and you're multiplying by this positive 2, you're going to get a negative 2. So when you expand and get rid of all the brackets out here, and again, this here is an implied positive 1, this here is an implied positive 1. Positive 1 by positive 1 is going to give you positive 1 outside here. So this here would be 1. Well, 1 squared is 1, and then 1 multiplied by 1 will be 1. And then you have 1 by 3, which is 3. And then you have negative 1 by positive 2, which will be negative 2. Remember, this here follows BODMAS, so this is why you had to work out the squares first. So 1 plus 3, 4 minus 2 is going to be equal to 2. And again, try and remember that when it is you have the same symbols, you're going to get a negative. And I like to remind students how to do this by just simply drawing some sad faces, because the eyes aren't the same. If you have negative, negative, you're going to get happy, positive faces because they have the same eyes. Back to this where, as I said, it helps you with the substitution. Let's say, for example, this, let's do another one just in case. Let's say x is equal to 2, y is equal to negative 3, and z is equal to 4. Let's say we have x plus 3y minus 4. No, just minus z. Right? So we do our substitution first off. So remember, you have your number as it is. You replace the symbol with the value in a bracket. So I'm just going to write in a different color. And then I'm putting back the green here. 3. And then I replace that. So minus 3. Then I put minus here. And then put in the 4. Now, as I said already, this is understood as an implied negative 1. So when you do the multiplication, you're going to end up with 2 by 2, 4. Then positive 3 by negative 3, as the positive negative implies when you're doing that multiplication, you get negative 9. So sad face, negative number, negative 9. So you multiply the values, you get 9, and the symbols would tell you get a negative. Negative, positive, you're going to get a negative value here, and 1 by 4 is just simply 4. So 4 minus 4 is going to be 0, and then you have minus 9. The next topic that we're going to look at is subject of the formula. And this here is just going to leverage some of the number properties, and I'm going to list it here right now. And you will see how these properties here apply for subject of the formula. Let's say, for example, I have the equation y is equal to mx plus c, and I want to make x the subject of the formula. What I have to do is identify first what I want to make the subject of the formula, and I'm already identifying it as x, and the location of x is here. Next, I'm going to remember what BODMAS is. BODMAS is dealing with how you perform operations on an equation, or how you perform operations on a series of values. In this case, we're going to use it to figure out what is being done to this x here. So we can see right away that what is being done to this x, first off, is we're going to be multiplying by this here, this m. So BODMAS, we're going to look at first anything that dealing with bracket very adjacent to the x. Next, we're going to look at anything with orders or powers very adjacent to the x. Then we're going to look at any division, multiplication adjacent to the x, and we already just identified the m. And then we're going to look at the addition, subtractions very adjacent to the x, and you can see that this here would be the third circle that we have. So we see in that x is first being multiplied by m, and then we're adding c. And then now what we do is reverse the operation. So I'm going to reverse the addition of c by subtracting c. And I'm going to reverse the multiplication of m by dividing by m. And I simply perform these list of operations backwards, and I would make x the subject of the formula. Now, if you check this here, you can see positive c minus c, and this here gives me 0. So I'm using the additive. I'll be using the additive inverse here, and notice here I will be using the multiplicative inverse here as well, because I'm going to get 1 if I take m and I divide it by m. So anyway, performing these operations in reverse order, I can see that if I minus c, since that's the last thing I did, that would be the first thing I do. So I'm going to minus c, and I'm going to get y minus c equal mx plus c minus c. And I can see right away here, this here gives me 0, as I already established here. And now I end up with y minus c equal to mx. And the next thing I have to do now is divide by m. So I divide both sides by m, and I will see that I have y minus c over m equal to mx over m. M's will cancel off and give me 1, as I already established here. So this here leaves me with x. So therefore, my final answer here will be x is equal to y minus c over m. Finally, what we're going to be looking at now is powers. Now, with powers, we're not going to worry too much about all the rules of powers. They're fairly straightforward, and they explain it. Everything is explained already for you in math. So I'm just going to point out the key formulas that we are going to be using when we deal with any kind of powers in physics. We're going to be using this formula here, a to the power of x equal to 1 over a to the minus x. Or we can say that a to the minus x is equal to 1 over a to the power of positive x. This here is used when we want to write all of the quantities on one level, and you would see this when we talk about derived units. Where would you see it? You would see it somewhere, and I'll give you a heads up right now, in kilometers per hour. To write kilometers per hour, you would see it written like this, or you would see it written like this, or you would see it written like this. Notice it came from a positive here to a negative here, and this is all because of this rule over here. The next one that we're going to be using is and these are used very simply when we have things like meters cubed or m cubed multiplied by, well, I shouldn't say it like that, I should say m by m. We'll have m squared, because this here is m to the power of 1 and m to the power of 1, which means m to the power of 1 plus 1, which is m to the power of 2. Similarly, for this one here, when we have a division, let's say we have m cubed divided by m, we can see that this here is m to the power of 1, so we have m cubed minus 1, which is m squared. And you would see how this is applied when we're deriving units. That's all the refresher information that I want to tell you about, and in the associated notes you would find some questions that you should do. All right, so that's all I want to explain for the refreshers in math. And what you can do is you can try the practice questions and submit it to me, and I will correct it and get it back out to you. Good luck.